Hey, this is Mr. Janes. In this video, we'll be talking about understanding linear equations and going beyond y equals mx plus b, or slope-intercept form that you might already be familiar with. Although we often use slope-intercept form, or y equals mx plus b, to graph a linear equation, we don't need to. Below are three other ways we can graph equations, even when they're not in slope-intercept form. The first method is to simply plot 2 points. A line is defined by 2 points, and so we can use the equation of a line to find at least 2 points. Remember, whenever we make a graph of any sort of equation or function, that graph represents all of the solutions for x and y of that equation. That means if there's a number for maybe x and a number for y, that when put into this equation, multiplied by 3 and 2, added together, those would equal 6. That x and y coordinate would be on the graph because that is a solution to this equation. Now that means we can literally pick any numbers we want to substitute in for x or y, solve for the other variable, get a coordinate and plot that on our graph, and we can use any numbers for that. So let's draw a little table to help us out here. So x and y. All right, x and y. Now I'm going to pick, let's say we said, say x was 2. What would y be? All right, got a little scrap paper pad here. So if x is 2, then I have 3 times 2. Remember, coming from this equation right here. 3 times 2 plus 2, I don't know what y is, so 2y equals 6. Let's solve this. 3 times 2 is 6, plus 2y equals 6. Subtract 6 from both sides. 2y equals 0, and oh look, right, if I divide by 2 at the end, y equals 0. So if x is 2, y is 0, and I can plot that point. X is 2, y is 0. Okay, 2 comma 0 right there. Okay, that's 1 point. What else? Well, let's pick another number. If x was, I don't know, say x is 4. If x is 4, what would y be? So if x is 4, then we substitute that into this equation again. We get 3 times now 4, because x is 4, plus 2y, we don't know what y is, equals 6. 3 times 4 is 12, plus 2y equals 6. Subtract 12 from both sides. 2y equals negative 6. Let me take this up here. 2y equals negative 6. So I divide both sides by 2. And y equals negative 3. Okay, so if x is 4, then y is negative 3. So let's plot that point. So 4 and negative 3. All right, and I could plot other points too, but I need at least 2 to draw my line. And you can get out your ruler and draw your line, just like I have right there. Make sure you have arrows on both ends to show that that line continues on continuously in both directions. At this point, I'd like you to go ahead and try to graph this one over here by picking 2 points to substitute in for x and then solve for y. Now you can choose any numbers you want to substitute in for x and solve for y to graph this, but for consistency, so we all have the same notes in front of us, try substituting in numbers like negative 1 for x, or try substituting in 1 for x and figuring out what y is. Plot those points on your graph, connect those with a ruler, so you have your line. Pause the video now, go ahead and substitute those in, graph your line. The answers will be up in 3, 2, Quan, make sure you pause this. Here are the answers. Alright, so it turns out if x equals negative 1, y equals 2. And if x equals 1, y equals 6. So now I can go and plot those points, negative 1, comma 2. And 1 comma 6. Oh, we're off the graph a little bit here. And then I can draw my line. And there is one way that we can graph a line without using the regular start at the y-intercept and go up the slope. We can just pick any 2 or even more than 2 points, plug them in or substitute them in for x or y, solve for the other variable, get a nice little table here, plot those points, and there's our line. There's also another similar way. What if we picked 2 easier points? The x-intercept and y-intercept are important points on a graph, and they're pretty easy to work with. That's because on a graph, the y-intercept, any point on the y-intercept or on the y-axis, is when x equals 0. I mean, that makes sense. If you're going to be on that y-axis right here, that's 0 for x, right? We haven't gone left or right on the x-axis at all. On the other hand, the x-intercept, okay, anytime a line crosses the x-axis, right here, is in fact when y equals 0. We haven't moved up or down from the origin, right? The x-intercept is when y equals 0. So what we can do is we'll do the same exact tables as we did before, but instead of using random numbers, let's try putting in 0 for x and solving, and 0 for y and solving for the other variable there as well. So on a scrap piece of paper, I can write if x equals 0, then this equation becomes 3 times 0 plus 2y equals 6. 3 times 0 is 0, plus 2y equals 6. Oh, I don't really even need that there, right? 0 doesn't change the value. So now we should have 2y equals 6. So divide by 2, and y equals 3. All right, great. If x is 0, y equals 3. Well, if y is 0, let's do the next one. If y equals 0, so the equation will look like 3x, because I don't know what x is yet, but I do know that y is 0, so plus 2 times 0 equals 6. 2 times 0 is 0. Again, I don't really need that in my equation anymore. It won't change the value of anything. So I'm left with just 3x equals 6. I'll divide both sides by 3 and get that x equals 2. So x is going to equal 2 when y is 0. Now these are much easier points to plot. In fact, this first point gives me the y-intercept. That's where x is 0. So 0, 3. That's our y-intercept. The second point, when y is 0, x is 2. That gives me my x-intercept, or when the line will pass through the x-axis. All right? And again, I can draw my line. And remarkably, this graph should look just like the graph we had above it. Well, it's the same equation after all. We just graphed it a slightly different way. Now it's your turn. For the second problem over here, go ahead and try and find the x and the y-intercepts by substituting in 0 for x and 0 for y into this equation and solving for the other variable. Then graph. The answers will be up in 3, 2, make sure you've tried this one. Here are the answers. So if x equals 0, let's see, I substitute in 0 for x, do a lot of simplifying on this side. 0 plus 1 is 1, 2 times 1 is 2, and then solve by adding 2 to both sides. I get that y must be 4. So let's plot that point. 0 for x and 4 for y. Again, that's our y-intercept, where x is 0. On the other one, if y equals 0, then put 0 in for y right there, substitute that in. This side just becomes negative 2. On the other side, though, I've got a variable, so I've got to distribute. So I'm left with 2x plus 2. And then to solve, I subtract 2 from both sides, and then divide by 2, and I'm left with negative 2 equals x. So when y is 0, x is negative 2. So y is 0, x is negative 2, right there, and I can draw my line. And again, if you notice, it looks remarkably like the previous line. I mean, it should. They're the same equation, just like the other one. The thing to remember about this is that both this first method and the second method are doing the same exact thing. I'm just picking points to substitute into my equation, plot those points, and then draw the graph. The only difference is in the second method, I was smart enough to choose 0 for x and 0 for y as my 2 points, and then solve to find the other one. As you can see, it's a little bit easier doing this because, well, for one, it's nice to have or to know what the x and the y-intercepts are, but also working with 0 and subtracting and multiplying 0, a little bit easier than some other numbers we've used. Of course, there is one other method. If you really like using slope-intercept form, or y equals mx plus b, you could rearrange the equation by solving for y, then graphing afterwards. Here's what I mean. We can take the equation we currently have and change it into the form y equals mx plus b by isolating or getting y by itself. To do that, we're going to solve the equation for y just like we would as if this was a number right here and y was the only variable left. So if we were to solve for y, the first thing we're going to do is get this 3x to the other side of the equation. So I'll subtract 3x from both sides. 3x minus 3x is 0, and we're left with 2y on the left-hand side of the equation. On the right-hand side, I cannot subtract 6 and 3x, so I've got to leave that as 6 minus 3x. What's left? Well, this is 2 times y, and we need y to be by itself, so I'll divide both sides by 2. Multiplying by 2 and dividing by 2 are inverse operations, and so we're left with just y on the left-hand side. On the right-hand side, I can divide all of these terms by 2. 6 divided by 2 is 3, minus 3 divided by 2. Oh, well, I can't. 3 isn't divisible by 2, so I'm going to leave this as a fraction, 3/2, or 3 over 2, x. Now, technically, I'm done. This is in the form y equals mx plus b, or slope-intercept. However, you might be used to seeing the slope on the other side of the y-intercept. If that's the case, you can just rearrange those. So y equals negative 3/2 x plus 3. Again, I still have the same slope, right? It's the coefficient on x. And I still have the same y-intercept. I've just put them in different orders. Now I can graph that. I know that 3 is my y-intercept. Okay? And I know that negative 3 over 2x, or negative 3 over 2 is my slope. So that means I've got to go, let's see, rise over run, down 3 over 2. Down 3 over 2. And then draw your line. And if you've done that right, it should look exactly the same as all the previous graphs. Just another way of graphing. Let's try and do the same thing on the second equation, and this time I'm going to do it with you. Remember, our objective is to solve for y, to get y equals mx plus b here. So what do we need to do? Well, pretend that, or just pretend this is any regular equation. We're going to start by distributing 2 into this expression. So 2 times x is 2x. 2 times 1 is 2. And I'll bring down the other side of the equation. Now we need to isolate y. So I'm left with y minus 2. So the inverse operation of subtracting 2 is adding. So I'll add 2 to both sides. Now I'm being careful that I'm adding 2 to this term right here. I can't add 2x and 2. Those are not like terms. But I can add 2 and 2. So I'm left with 2x plus 4. So y equals 2x plus 4. Now I can graph this using slope-intercept form. I know that my y-intercept is 4. And my slope is 2, also seen as 2 over 1. So my slope would be over 1 up 2. Or I can go in the other direction as well. Okay. Now I can draw my line. And just as before, I obtained the same graph as I did using the other methods. Again, same equation, I should get the same graph, just a different method. To recap, there are really 2 ways we talked about graphing here. Instead of just using y equals mx plus b, one method is to pick any points for x and for y, substitute those into the equation, and graph the result. It's sometimes easier to use 0 for x and 0 for y. These are usually end up making the math a little bit easier and give us the x and the y-intercept to boot. The other option is to change your equation into slope-intercept form by solving for y. You might have to subtract something from both sides, divide. To get y, you may have to simplify some sort of equation or expression a little bit. But in any case, the other option is to isolate y, get y equals mx plus b, and then graph it the old-fashioned way. I hope you've enjoyed this video and learned a little bit about understanding linear equations going beyond y equals mx plus b.